go on, I want to explain and apologize. When Jim first called me and said, can you do the presentation next month? And he suggested that it be PEX, and I said, well, technically I'm not working for a PEX company right now, so I can't speak with the full authority. I might have the knowledge, but I want to be careful and not say things that represent some one company or several companies. And except for Uppa, I think I've sold PEX for everybody else. So what I wanted to say is we're going to talk about PEX a little bit in here, but the list of topics that Nick came up with are very worthy of discussion. They're real more practical how-to kind of stuff, and we might make that next month's thing, But for right now, I'm going to talk about plastic piping and commercial construction, and this is a sort of a personal thing with me in that I got you guys know I've sold truckloads of cast iron and copper and just about in strut and every kind of thing that there is in the trade, and so I try to be as neutral as I can and try to be as fair as I can. But I think that plastic is slow to be used in commercial construction here in California, especially on the waste side. So I'm encouraging people to do more of it. And of course, on the water side, we've got a pretty good track record so far, but we could sure use a whole lot more. So that's sort of my slant on this, that I want to talk about the science of it a certain amount, but I also want to show you, do some comparisons, this versus that, and at the same time, encourage you to use more of the less metal and more plastic is where I'm trying to go with this. Okay, so my bias up front. Okay.
Time's up.
Thank you for coming.
So we start out with this age-old principle: there is no perfect pipe, and if you think you got it, just wait long enough. Somebody will find a way to screw it up. So, number two, something better will always come along. So we think we got the hot stuff today, but you know what? You never know. Somebody's going to come up with something better. So let's keep an open mind about it. And look, here's wood pipe. What were they doing 100 years ago, right? Yeah. Okay. So the important thing is pick the right pipe for the job. So in water, the plastics that you've got available to you are CPVC, PEX, and polypropylene. Now you may know that polypropylene is under that trade name Aquatherm, although they're not the only guys, they're just the biggest guys here in the United States. And generically in waste piping you have PVC and CPVC. And I deliberately left ABS off because ABS is pretty much, even though it's still commonly used, it's across the whole country. It's a very small part of the market. PVC, even in our backyard, is taking over a lot of that.
And CPVC for waste, are you referring to standard waste? Are you referring to chemical waste?
Listen and you will learn.
There's no perfect pipe.
To answer your question very briefly, what I'm going to show you in a little later on is that there are parts in a building that are plenum rated.
Oh yeah.
Okay, and you can't do anything with them in those areas with plastic unless that plastic won't burn.
Well, what about the fitting for CPVC that's not in a drainage shape? Might be getting ahead of the slide here, but
that's why Mr. Spears took his molds for PVC fittings and poured CPVC in them, and so now we got all the same
you got
fittings.
the whole system.
Yeah.
But that is the one you're talking about.
Right.
For chapter 8.
Yeah. But the CPV stuff can be used for acid waste and it can be used for normal waste. And it depends what your need is, and you'll see that. Okay. So before anybody gets into using a lot of plastic, Tom, to your point that just because it looks easy doesn't mean it is. Okay, so the first thing is you got to learn from somebody. And as you guys know, code's pretty important. You got to know things about whether it's rated for flame or not. You got to learn the sizing rules, the correct methods for design and the correct methods for installation, the right tools, and tools make a big difference sometimes. And you also got to know about compatibility, because there are things that hurt metal and there's things that hurt plastic. So you got to know what those are. Okay. So as far as the code, basically Chapter 6 is going to help you with water. 7 is going to work you with waste. And I put installation standards in here because I use this class in places outside of California. Or people still on the old code. Then there are places that are still on the old code. They took the installation standards out of our current code.
Right.
And they try to work them into the body of the code. But if you go over to Clark County, Nevada, they're still working off the 2012 code, and they use the installation standards. So, and the installation standards are probably the best part of the book, for the working man anyway. Okay, so the same whole thing about smoke, about the plenum rating is, if you're in that part of the building where the air is conveyed in a non-ducted way, it has to meet this ASTM E84 or its twin sister UL 723. And the perfect example of that is the area above us here, above this drop ceiling. They may be ducting the chilled, the cold air or the hot air, but the return is going back just in the open space of the building. Now, as Larry knows, that's an inefficient way to do it. The state of California already says houses cannot have an unducted return. However, commercially, it's still allowable for a little bit longer. Okay, so water piping. One of the first things you find out is that the ID of plastic piping is different than the ID of copper tubes. And this affects your velocity. Obviously, if the pipe's a little smaller, to get the same volume of water through it, the water has to travel just a little faster. So if you look at the tables in the book, you'll see that a lot of times you have to upsize your plastic pipe in order to have the same gallons per minute and keep it under the feet per second. As you know, 8 feet per second cold, 5 feet per second hot. Okay, so there's tables like this in most manufacturers' books, and you can't see it from the back there, but it's designed. It says here. Excuse me, I'm sorry. You have your gallons per minute on one side, and then you have your friction loss, and you also have many feet per second calculated in there. So yes.
Marlo, does each manufacturer have their own flow velocity and friction loss chart, or is it a universal?
It's pretty much universal, but they all do it up their own way. So
Yes.
A lot of them print it in their literature and their sizing.
Yeah, because my installation book that I hand out, the plumbers are looking at it, but the engineers are looking at it too. So I got to have the really technical stuff, and I got to have the practical stuff in the same book.
Well, as a PEX expert, you know that the expansion method is a bigger ID of the insert fitting than a crimp method. So they're going to have their own table to substantiate the difference in those flow rates.
Well, if I may comment on that for a moment.
Sure.
That's such a con.
Reading the table,
I
reading
know,
the
but
R number in LA.
but you understand the concept of Venturi.
Oh, yeah.
Okay, so if Wurzbo wants to say that their fittings have a bigger ID in it, and that's going to have a tremendous effect on the system, poo-poo.
They
Okay?
told me that, and I know that's where I got it.
Because that little length of fitting compared to the great amount of pipe is like
That's what
an ant on
their
an elephant's
competitor
butt.
said the same thing.
Yeah, but don't tell the keyline guys that. Okay?
Less
No.
than insignificant.
Yeah, yes.
That's why type A is better than type B.
So I can quote you on the poo-poo.
Yes. Okay. Now, the ways you put it together vary. You've got solvent welding, which is really gluing it together. Okay. But we call it welding because just like heat welding, you're melting things together. We're just using chemicals.
Process.
Yeah. You might say we treat the pipe with drugs. Okay. Okay. Threading. Now you can thread CPVC. Flanging. Yes. You don't directly flange. You attach a flange at the end. Grooving. You can groove some of the PVC and CPVC. Fusion is what you usually do with polypropylene. You physically melt it together with a heat tool. Crimping is one of the ways that it's done with PEX, and cold expansion is the way that some PEX manufacturers like to do. They expand the end of the pipe and let it shrink back down. Okay, now, I'm showing you tools that can be used for PVC and CPVC. Now, Bob, you got any of these in your toolbox? Okay. Well, you know, on the left-hand side, you got a tubing cutter, except the one you use for plastic has a different wheel in it because it has to penetrate a thicker wall, and you'd actually need a thinner blade on that. Okay, this one tool here, this cone-shaped thing, that takes the burr out of the inside of the pipe, and at the same time, it also helps to put a bevel on the outside of the pipe. Okay? And this other tool down below it, that one right there, that's just a fancier version. This is the $20 tool. That's a $65 tool. Okay.
I can get it for 55.
Good.
I get it for free.
This tool over here, you probably wanted something out of Star Wars. That's what you use on large diameter pipe to put a bevel on it, you know. And this over here, here's a tricky little tool for putting a bevel on too. Now this ratchet cutter, I pointed that out to you. It's a quick and easy tool, but if you're working with cold plastic below 50 degrees, it'll crack the pipe, so you don't use it. Yes, sir.
That tool that was to bevel
one?
the pipe.
This one here?
For us, like in the trade, I think that would take like a very long time for
Which one? Which
the
one?
type of
The
one on the bottom,
conic-
the
the
right-hand corner on the bottom.
That one?
Yeah.
That's the fastest one.
That would probably take us way too long because we have like large quantities of pipe going out to the.
That is the one I give to guys on commercial work that are using anything between 1.25 and 4 inch. It's the fastest beveling tool on the market that isn't
You can
powered.
just make one pass, right?
Well, sometimes you spin it twice, but that's all you spin it, yeah. Yeah, so I'll demonstrate for you. I got one out in the car, okay?
How long would it take
To demonstrate?
to bevel it? That one.
Under
10, 20, 10 seconds, you know? Yeah. You can see, you can play with it, yeah. Believe me, I wouldn't recommend it to you if, yeah.
That's another meeting too.
Yeah.
Play
Okay.
with it.
Let's do a demonstration in the parking lot.
Okay. Now for PEX, for PEX, these are the common tools. You gotta cut it with something, and usually this little quickie cutter is the best thing. If you're crimping, you use a tool that looks like this. If you're cold expansion, here's your manual tool, and then here's your power tool, okay? And once you get above 1 inch, it gets really sticky trying to expand it. And talk about something that takes a lot of time. Cold expanding PEX at above 1 inch is terrible. Polypropylene, here's your fusion tool, and that probably reminds you a lot of what you also use for your polyethylene gas lines. Pretty much same stuff. Okay. Now, compatible materials or incompatible materials are troublesome, and things like oil or oil-based paint, tape, wire, and some spray foam insulations. Briefly, just to, you probably right off the top of the bat, you understand why oil and paint would be a problem. But the reason, and we take it for granted that flux is going to be bad. But this thing about tape and wire, most people don't realize that almost all your tapes start out as PVC, but PVC is rigid, right? So how do you get it to be bent to go around wire and to wrap around things? You put a softener in it, a plasticizer. That plasticizer, if it comes in contact with plastic pipe, some of that plasticizer moves out of the insulation or the tape and into the pipe, and over time it makes a soft spot. And that becomes, especially in a pressurized system, becomes a leak and a crack. And I'll show you a picture in a minute. Spray foam insulation, you don't see as much around here, but you go to a desert area or you go to a very cold area, they don't put fiberglass insulation in the bats. Some guy comes out in a hazmat suit and he sprays into each of the bay, this insulation. Now, there's chemicals in there that hurt plastic pipe, and secondly, what comes out of that's applicator, that's the end of the hose, is 400 degrees, so it melts pipe. Okay. So these guys that just go in there and spray it all over, no. You got to be very careful. It's got to be done in the right way. And I tell people, you can spray it anywhere you want, but don't let it touch my pipe because
Plastic pipes smell good.
Okay. And this is a warning that we put out for a lot of people. And just you notice it says solder flux on here. We do include it on it. And we also talk about intumescence. Now, intumescence, that's usually your fire stopping, something that you put around pipes when it penetrates a wall. And how does it work? When it gets hot, it expands. But some of it has the right stuff in it, and some has the wrong stuff in it. So we have to be careful and select that. Now, here's an example of in this installation, the worker knew that he had to put a mid-story guide. That's all required on all your domestic water piping. And for that matter, waste piping too. And so, but the clamp that he used is the same one you use on steel pipe. It's got sharp edges. That's no good for plastic. So he says, I'll protect it. I'll wrap 10 mil tape around it, you know. So two wrongs do not make a right. Okay. Now, this is pipe that had wire laying on it for years. Okay. So about 5 years after that, it starts dripping. And if you get up close to it, you see this tiny crack in here. Yeah.
And that's from the wire touching it?
Yeah, because it weakened that spot, and that became the place where the leak occurred. So it really does happen, you know.
Is that from the coating around the wire?
Yeah, it's from the insulation. Now, so if I may encourage every inspector in the room, make them follow the electrical code. The electrical code says no wire shall be hung from any other material. It shall have its own suspension, whatever way, and it shouldn't be touching anything. Okay, but if you go out in this wood frame construction, it's all over the place. I mean, I got a million pictures of it, and this is just an example of the bad stuff. Okay. So Spears and many other manufacturers put out a list of the things that we think that are safe to be used with our products. So this happens to be our list of fire stops. Here's other things like thread sealants. Look, we got like a dozen different kinds of pipe dope that we've tested and we know that's safe. So, you know, it's not that hard. You got lots of choices. We also have things like cutting oils. Why would I have cutting oil and gasket lube on there? Well, think about it. You're in the shop or you're out on the job. 1 minute you're working with gas pipe. The next minute somebody comes along and says, "Hey, pass me that piece of PVC so I can put it in here." Well, you got cutting oil and you got pipe dope all over it, and if it's not the friendly kind of pipe dope or the friendly kind of cutting oil, you've just contaminated that pipe. So what we tell is a shop, we say, look, let's just clean all the old stuff out of here. Let's have good pipe dope, good Victolic lube, you know, good cutting oil, everything, and that way you can't possibly screw up, you know. But so that's our approach to it. I know, Larry. It's
He still puts $1 under his pillow when his tooth comes out.
okay. So these are the things. These are the things you worry about. Okay. Now hangers again. With plastic pipe, we always got to remember that plastic pipe expands when it gets warm and it shrinks. So it's always going to move. The question is how much it moves. So we always have to have smooth edges, or quite often you have like rolled edges on the hangers. If you can't get the smooth edges and you can't get the rolled edges, then you put felt on them. Always remember the sticky side goes on the metal, the non-sticky goes on the pipe.
Yeah, he said.
Oh,
Don't be so cheap, buy the hanger that's already felt insulated.
so,
Yeah.
So you noticed here on these hangers, they got those rolled edges to them, okay? Now also too, you see this little fella here? That's for where we all have seen the little isolators that are used even on copper when it goes through a stud. Okay. Well, this one's specifically made for the square holes in steel studs. Okay. So you can run wire through it or you can run pipe through it. Okay. I don't think it has an IAPMO listing, but I don't think that's important. So the three materials for water piping: CPVC, PEX, and polypropylene. Okay. So this is what, if you notice here, this system, he's run Schedule 80 for a while, then he's converting over to the copper tube size material. The copper tube size material is sort of the cream color. Okay. Here's your two colors of PEX, Tom. Okay. Okay. And here's your polypropylene material. Yeah. Why do people want to use plastic?
Don't know.
Well, there is a reduction in labor, but not always. As been pointed out here, sometimes the whole reason we go to plastic is because we want to resist corrosion. Most of the time, the corrosion is from water that's got something in it that's going to eat up metal pipe, such as then Highland and Colton, even parts of Irvine had that problem. Also, you don't get mineral buildup inside of your pipe. Metal pipes, sooner or later, they all get some kind of collection on the inside. And last of all, the plastic is quieter, so you don't hear your water running so much. But we always have to worry about expansion and contraction. So in a plastic system, we have to allow it, and sometimes that means we have to leave room at the ends of the runs so we don't bump up into structural members when the expansion does occur. But it also means we have to allow for the movement of the pipe. If you think about it, you got a long run, you got a lot of branches on it. You get too much movement like this, you're going to snap a branch off. Maybe not the first week, but after 100 cycles, it's going to happen. So you build into the design things like loops, offsets, or changes of direction. These will compensate for that. And we could talk for a long time about that, but here's the formula if you want to design one of those and calculate how much you have to put in. Do you think you guys could do this with apprentice math?
Okay. You worked up that formula on your way in this morning.
Yeah. It's on the back of my. Okay. But another solution besides loops is expansion joints. And here you've got a piston type, and there you've got a flexible type. Well, all of these account for the movement in the pipe.
Mario, the expansion joints, do they have a lifespan, or are they just forever?
The one on the left, well, the way we build them with 3 O-rings in them,
Yeah.
that's going to last.
Okay, and does hard water affect that at all?
Generally not.
Okay.
Not. If you got to put the right rubber in it. That's what it boils down to. Okay.
Okay.
Yeah.
Okay.
Yeah. And Larry, for your benefit, because you're a designer, okay. You need a detail like this on your plans when you use an expansion joint.
Email it to me.
Okay.
That would be really great.
Because what this says is you have to have guides right here so the pipe goes straight into it. You can't have it crooked or it'll kink on you. And then you got to restrain the ends of the run so those don't move. So all the movement occurs within, not.
Yeah.
Good job.
Okay. So now I'm going to give you a very brief comparison here of different features. So you can see here with PEX you're limited up to 3-inch. Although there are people in Europe doing bigger, whereas CPVC 24 is pretty normal. Polypropylene right now they're only up to 18-inch here in the States. As far as how the joining goes, CPVC and PVC they're going to be joined by solvent cementing, or you can thread it. Polypropylene can only be done with fusion. PEX, you got your choice: expansion or crimp. And then grooving, you can groove your PVC and your CPVC.
What about push fit, Mr. Orlando?
When that gets in the code, we'll talk about it.
Okay.
It's in the code.
What, shark bite?
Yeah,
Well,
isn't that in the code?
Sure. It's improved material.
Larry and I, 2 points.
I did not see that in the code book, so I
It's a
apologize.
listed fitting, it's in our report, it's got everything but Benny Crocker.
Well,
Is it specifically mentioned in the code?
okay. All I can tell you is Spears is working on an ASTM standard for a push fit fitting for plastic, but I hadn't seen one that. But if you're right, I can stand corrected.
I'll email you this thing.
Well, hey Mario, let me ask you something. In threading the CPVC, how does that affect its longevity?
Well, see, we do nipples at the factory. I don't want to see you guys cutting it in the field.
Okay.
So if you want a threaded piece of pipe, we'll sell you a nipple. You cut off one end and that.
There you go.
Yeah.
Okay.
Yeah.
Typically, they wouldn't have to thread the pipe. You're talking more like a male adapter that has the threads on the fitting?
Right. We also have we have male and female fittings. Yeah.
You can't thread them.
Now flexibility. PEX wins. Okay. You can bend CPVC in the smaller diameters, but PEX wins it overall. Plenum ready. The only one product for water pipe made in plastic is CPVC.
And that meets the 50 and the 100 and the smoke and everything?
Yeah,
Okay,
yeah, okay.
that's good.
Now,
That's the US
Now-
723, right?
and, yeah, / E84, okay. Now, I wanna point something out here, and I think this is, important for everybody to realize, and I'm not the primary guy to have done all the research, but we talk about chlorine resistance. Now, you all know that what the EPA requires in terms of clean water when it comes out of your tap is pretty strict. But there's two things happening in our water systems today. One is that the systems are getting longer. In other words, from the treatment plant to the faucet is a lot further than it used to be, which means that the water's sitting in the pipe, and all those little buggies that are still in the pipe can grow. So when it comes out of your faucet, it may not be as clean as it's supposed to be. The second thing that's happening, because we're all flushing with lower flush toilets and we have lower flow aerators and shower heads, the water's not moving through the pipe as fast. So these bugs have more time to grow. So how does the water agency take care of that? Chlorine, and it actually, what it's doing now is they're adding ammonia to the chlorine, and that's called chloramine. Chloramine loves to eat things up. It certainly works on copper. If you happen to have old copper with leaded solder, or you got old cast iron mains with leaded joints, it's going to suck the lead out. Okay, so we're seeing a lot of copper that's getting hurt, and we're also seeing that the LADWP, and Cook Dean's not here to defend himself, is now adding buffers to their water system. I mean, I've been at their injection stations helping them hook up the plastic pipe on that. But the idea is that they're sticking chemicals in to offset the chloramine because the chloramine's tearing the pipe up. Okay. So what pipe is going to stand up to the chloramine the best? Well, what we're finding out is that polypropylene has some resistance, but eventually it does affect the inside diameter of the pipe. You start to lose wall thickness. PEX, given time, you will have failure. Given time, and I'll explain that in a minute. But CPVC, chlorine can't hurt it because CPVC is made out of chlorine. So, you can't hurt it. Now, about the PEX thing, what I want to explain is this, that the fundamental of PEX is that to take, what you're doing is you're taking ordinary polyethylene and you're turning it into PEX by getting the molecules to connect to each other, what we call cross-linking. To make that happen, you have to do certain things to it, certain methods, and there's 3 different methods, and we can talk about that another day. But the important thing is, it doesn't have any natural resistance to chlorine. So what they have to do is they have to add what they call antioxidants into the formula. The more antioxidants you put into it, the longer and stronger it can fight chlorine. But you just can't put a forever amount. There's only so much room in that molecule to add it in. So what happens is sooner or later you're going to have a failure in PEX from the chloramine if they keep using that chloramine. All the reasons why we went to PEX were based upon the old days when the concentrations of chlorine were lower and there was no chloramine in it. Plus we listened to the Europeans, and the Europeans don't use chlorine, so they don't even worry about it. But we learned to do PEX from the Europeans, and they had a good idea. It's just that our little system of chlorination is dangerous for PEX. Are you going to have a failure tomorrow? No. But in certain parts of the country where it's been in for the longest period of time, it's starting to show up. And guess what? The systems that have the least amount of antioxidants in it, and I won't mention any brand names, but those are the ones that are having the problem, okay? And their rep is not in the room today, so.
It's a say.
It's a say.
Say.
I'll edit it.
Until Michael turns off the recorder.
And last of all, I'll talk about tools. Well, PEX does have specialized tools, and if you get to the big stuff, it's very expensive. CPVC has very common tools, moderately expensive, and polypropylene, they have really those very, very expensive tools. So if you're worried about investment to get started, it's an issue. So now, I gotta put my plug in, only CPVC meets the flame and smoke and can be used in plenums. So that's the reason for it. And that
And
applies,
that's a water pipe, right?
and drainage pipe.
But the test was done with water in it.
No, it isn't. Done dry.
Done dry?
Actually, it's done both ways, but yeah.
I don't think it would matter, it's the material itself burning.
Well, they tested it with the water in it because that has helped keep it from
burning
catching
quick.
fire, yeah.
Ira, you will love this, okay?
I will.
I'm gonna give you you love science, right? You used to watch Mr. Wizard, right? As a
Yeah.
kid? Okay. You're too young to know what Mr. Wizard was, but it was a cool thing. Okay. The LOI, not LOL, but LOI means limiting oxygen index. What that says is that you gotta have a certain amount of oxygen in the air for the stuff to burn, okay? So in the case of cotton, polyethylene, all these other things, they burn because they need less than 21%. CPVC, you gotta have 60% oxygen in the air to make it burn. So it just can't burn. Unless you get an oxyacetylene torch, when you got the acetylene and the oxygen coming out at the same time, then you got a shot at it. And so, while the other guys put off poisonous gas and smoke, all we do is we burn the pipe a little bit. See here? Okay. That's what flame does to CPVC, but you don't get any smoke. It doesn't keep burning or anything. Now, we're getting close to the end of your time, okay?
Yeah.
So I'm gonna do this very quickly, and I'm gonna skip the big details of the DWV, but I'm gonna show you some jobs here. You see this twin tower downtown? It's now almost up to the 32nd floor. All the domestic water piping 2-inch and smaller on that building is CPVC. Okay? They use stainless to get it up to the floors, and then distribution is all CPVC. Okay. See, there's the stainless. Okay. And then also the HVAC guys use our Schedule 80 to distribute the hot and cold to
The
their.
condenser water.
Yeah.
Those are condenser water risers.
Yeah. And I didn't train those guys, so it's a little sloppy looking, but you know. Okay, for PVCWV,
Whoa.
I'm gonna, okay, this came out of the old Imperial Palace in Las Vegas when they converted it to the Link. Okay.
Well, they use MSG in their cooking.
Yeah. This came out of the Venetian.
GMOs, yeah.
This pipe came out. This is what happens in Vegas, but it happens here too. Okay. So I said, why are you guys using plastic? I suggested to them, let's use why are you using iron? Let's use plastic. So that's a whole nother thing there. But let me show you here. This building, what we've done here is we've used expansion joints to compensate for movement, and this is a special
I've seen
shield,
that.
the shield that keeps it quiet. So
I've seen the
it's
guy in Atlanta promote that.
Yeah.
Cornwall.
Yeah. Okay. So what we tell people is use PVC as much as you can, but when you get into a plenum area, use the CPVC version of it, which we originally invented for acid waste, but it can handle ordinary waste. So the top 2 floors of this tower, the bottom 20-some floors are done in regular PVC. We had it repipe. We worked on the repipe. The top 2 floors, because it's a plenum thing, they use CPVC, this gray material here. Okay. Right now, they're ripping out all the cast iron out of the Flamingo, and because all the waste piping is in a plenum, every bit of the new stuff going in is the gray stuff. Okay.
What's the price difference between PVC and CPVC?
Almost better than double.
Really?
Yeah. But since you can use it, and see, they were repiping these towers every 10 years, you know. So now they're never gonna have to repipe it. Well, thank you very much, and we can talk more later.